Hello friends, in last lecture we learned the problem regarding all methods, Galerkin methods, Petro-Galerkin methods, subdomain method. But when last lecture's problems, the problem involved in primary variable condition only, that is nothing but essential boundary condition only. But in these sums, we will get the boundary in two types of boundary condition. One is primary variable boundary condition and secondary variable boundary condition, which is we also known as essential boundary condition and natural boundary condition. So let's see how can we solve by using two boundary condition, and by using this method Galerkin, Petro-Galerkin, least square method and Rayleigh's method. The remaining the table factor, weight function factor will be same. Step number 1 is approximate polynomial. So we will see first what is the order of this given differential equation. If I am saying this differential equation, I am getting order of differential equation is 2. So my approximate polynomial our approximate polynomial order should be 2 plus 1, that is nothing but 3. So we will write y is equals to c0 plus c1x plus c2x square plus c3x cube. Okay, so now we will see the what is the boundary condition. So boundary condition are, one is essential boundary condition and second is a natural boundary condition. So first we will apply both boundary conditions. So my first boundary condition is y of 0 is equals to 1. That means that when the value of x is equals to 0, then the value of y is equals to 1. So I will put this boundary condition in this above equation. So I will get y of 0. So this is as a 1 and put x is equals to 0, 0. So it will be 0. So I will get c0 is equals to 1. So now second boundary condition is saying that y dash 1 is equals to 0.1. So this is natural boundary condition. Y dash is nothing but dy by dx. So but we don't have any y dash term here. So we will differentiate this equation. If I differentiate this equation, so I will get c1 plus 2c2x plus 3c3x square. So now I've got this differential equation of this approximate polynomial. So now I will put this variable in this equation. So this is become y dash 1 is equals to c1 plus 2c2 into 1 plus 3c3 into 1 square. So y dash 1, which is nothing but 0.1. So I will put here 0.1 plus I already got the value of c0. So now we will c1 plus 2c2 plus 3c3. So this is my equation number 2. Okay, so my order of different approximate polynomial is 3. So you have to solve this approximate polynomial for 2 parameter. That is nothing but if I am seeing this approximate polynomial, I will get 4 parameter. One is c0, one is c1, one is c2 and one is c3. So I got this 4 approximate polynomial, but I should keep this as a 2 only, because I have to solve this approximate polynomial for 2 parameter only. So now I have c1 also, c2 also, c3 also and c0 also. So let's see what happened. Y is equals to, so if I am seeing that this is c0 is equals to 1, so I will put 1 plus c1x plus c2x square plus c3x cube. I am putting c0 is equals to 1 here, but if I am putting c0 is equals to 1, so that after putting c0 equals to 1, I will get c1, c2 and c3 3 parameter, but we want 2 parameter. So from this equation I will make the value on c1. So I will get c1 is equals to 0.1 minus 2c2 minus 3c3. So I got this value of c1. So now I will put this c1 value in this equations. So this is become 1 plus 0.1 minus 2c2 minus 3c3 into x plus c2x square plus c3x cube. So this is big, though this is also c2. Okay, so I got this equation 1 plus 0.1 minus c2 2c2 minus 3c3x plus c2x square plus c3x cube. Now I will solve this equation. So this is become 0.1x minus 2c2x minus 3c3x plus c2x square plus c3x cube. Okay, so if I'm gathering this c2 and c3 term, I will get 1 plus 0.1x. Okay, so this is c2, again this is also c2. If I'm taking c2 as a common, so I will get x square minus 2x into c2. If this is c3, this is also c3, I will take c3 as a common, so I will get x cube minus 3x into c3. So this is my approximate solution involving two parameters. So I got this final equation from step number 1. My parameter should be c2 and c3. So I got the step number 1 equation, y is equals to 1 plus 0.1x plus x square minus 2x into c2 plus x cube minus 3x into c3. So now step number 2. So step number 2 is nothing but, so step number 2 is nothing but we got the value of y. Now we have to find weighted integral form also. So for finding weighted integral form, you always find residue. So my step number 2 is nothing but to find the residue equation. So step number 2, you have to find the residue equation. So what is residue equation? In last sum, we know that how can we find the residue equation? Our residue equation is nothing but our differential equation. So I will put r is nothing but our differential equation, which is d square y upon dx square plus 3x dy by dx minus 6y. So what is d square y by dx? So we already find, we have to find dy by dx, we have to find d square by dx. So if I'm saying that my y is 1 plus 0.1x plus x square minus 2x into c2 plus x cube minus 3x into c3. So we will find the first derivative. So after finding dy by dx, you will get, so one derivative is 0, so you will get 0.1 plus 2x minus 2 into c2 plus 3x square minus 3 into c3. So next second derivative will be d square y upon dx square. So this is become 2c2 plus 6xc3. So this is my dy by dx and this is my d square by dx square. So now I will put this dy by dx and d square by dx square in this residue equation. So this is become r is equals to, our d square by dx square is 2c2 plus 6xc3 plus 3x into 0.1 plus 2x minus 2 c2 plus 3x square minus 3 into c3. So 2c2 plus 6x3 plus 3x 0.1 plus 2x minus 2 c2 plus 3x square minus 3 into c3. So now we will solve this equation. I will get 2c2 plus 6x c3 plus, I will multiply this 3x throughout this bracket. Okay, so after multiplying this, I will get 3 into 0.1x plus 6x square minus 6x into c2 plus 9x cube minus 9x into c3. Okay, and this minus 6y term, so this is become 6 into y is nothing but our approximate polynomial. So this is become x square minus 2x into c2 plus x cube minus 3x into c3. Okay, so I will multiply this 6 throughout this bracket. After multiplying this 6 plus 0.6x, so due to this minus sign, this bracket sign will be changed. So minus, this is become minus. This is also minus 6x square minus 12x into C2. Again this multiply to this bracket, I will get 6x cube minus 18x into C3. Again due to this minus sign, this sign also change. Okay, so now I got this throughout big equation. Now I will bifurcate this equation as per parameter. Okay, so this is become, if I'm seeing that C2 parameter, so I got, this is my C2 equation, this is also my C2 parameter equation, and this is also my C2 parameter equation. So I will collaborate this all these C2 terms. So this is become 2 plus 6x square minus 6x minus 6x square minus 12x into C2. Okay, after that C2 we will see about C3. So this is also C3 term, this is also C3 term, and this is also C3 term. So if I'm seeing this C3 terms, so I will get plus 6x plus 9x cube minus 9x, and this is become minus 6x cube minus 18x into C3. Okay, so this is also C2 term, so you have to take bracket also. Okay, so I got C2 to 6x square minus 6x, and this is 6x square minus 12x, and C3 term is 6x plus 9x cube minus 9x minus 6x cube minus 18x C3. So now constant term remaining, so this is 3 into 0.1, and this is become plus 0.3x minus 0.6x and minus 6. So this is my equation. So I will solve this equation. So if I'm seeing that this is plus 6x square and this is minus 6x, so will become cancel. So due to this minus, this sign will be changed. So this is minus, so this is become plus. So I will get 2 plus 12x minus 6x, which is nothing but 2 plus 6x C2 plus 6x minus 9x, but due to this minus sign, this will become 18x. So 6x minus 9x, which will be the minus 3x, and plus 18x, which will be the 15x. So this is become 3x cube into C3. This is become minus 0.3x minus 6. So this is my residue equation. So finally I got R is equals to 6x plus 2 into C2 plus 3x square plus 15x into C3 minus 0.3x minus 6. So this is my residue equation, and this is the end of step number 2. Okay, now step number 3, we will see step number 3. So step number 3 is, we already know that the step number 3 is a weighted integral form. So we will write weighted integral form. Okay, so we know that the formula for weighted integral form is nothing but our domain wi r dx is equals to 0. So if I'm saying my sum, my domain is x is lies between 0 to 1. So I will write here 0 to 1. Wi our weight function and will be changed according to methods. So this is wi into r. So r is nothing but our residue, which we find in step number 2. So this is become 6x plus 2 into C2 plus 3x square plus 15x into C3 minus 0.3x minus 6 bracket complete dx is equals to 0. So this is my weighted integral form equation. By using this equation, we will solve this all method. So my residue equation become 2 plus 6x C2 plus 15x plus 3x cube C3 minus 0.3x minus 6. So I will rearrange this equation. So by rearranging this, I will get 6x plus 2 into C2 plus 3x cube plus 15x into C3 minus 0.3x minus 6. So my step number 2 is over. Now we will find the step number 3. So my step number 3 is weighted integral form. So my weighted integral form, we know that the formula for weighted integral form is our domain a to b wi r dx is equals to 0. So where wi is nothing but weight function and which can be changed by using different method. If it is Galerkin, there is a different weight function. If it is Petrogalikin, there is a different weight function. If it is least square, there is a different weight function. So it will be changed according to my methods. So now my domain is 0 to 1. So wi, which is our weight function, will be written as it is. So r is nothing but our residue, which we'll find in step number 2. So this is become 6x plus 2 into C2 plus 3x cube plus 15x into C3 minus 0.3x minus 6 dx is equals to 0. So that is the end of step number 3. Now we will use this weighted integral form equation for solving this OR method. So I got from step number 1 this approximate polynomial equation, and from step number 3 we got the weighted integral form. So now we will use this two information by using this method. So first we will start method number 1 is Galerkin method. So what is Galerkin method? So we will use this weighted integral form for solving this Galerkin method. So I already got the equation of r. Just we have to find the wi. So what is wi? If you see this table, so Galerkin method. For Galerkin method, the weighted function is required is coefficient of ci in y. So what is y? So y is nothing but our approximate polynomial equation. So this is my approximate polynomial equation. Coefficient of ci in y. So what is ci? Ci is nothing but our parameter. So if I am seeing this approximate polynomial, I get two parameter. So this is C2 and this is C3. So coefficient of C2 and C3 in y. So you have to solve for two equations. First I will put coefficient of C2 in first equation, and after that I will put coefficient of C3 in second equation. So our wi will be, so w1 will be coefficient of C2. So that is nothing but x square minus 2x. And for second equation, we will use the coefficient of C3. So now I will put this W1 in this weighted integral form. So this is become 0 to 1 Wi. So that is nothing but x square minus 2x into 6x plus 2 C2 plus 3x cube plus 15x into C3 minus 0.3x minus 6 dx. So this is my bracket and is equals to 0. So I put W1 in weighted integral form. Now I will solve this bracket and after that I will solve this integration. So if I am solving this bracket, so this is become 0 to 1. I will multiply this x square throughout this equation and 2x throughout this equation. So if I am multiplying this x square, this bracket, this is become 6x into x square, that is nothing but 6x cube. This is become 2x square into C2 plus this is become 3x raised to 5. This is become 15x raised to cube C3. This is become minus 0.3x cube minus 6x square. So this is my one bracket. Okay, so I multiply this x square throughout this equation. Now I multiply this 2x throughout this equation. So my equation become minus. So 2x into this is become 12x square. This 2x become 4x into C2. Okay, plus this 2x should be multiplied with this bracket. So 2x into 3x cube. So that is nothing but 6x raised to 4 plus 15 into 2, that is nothing but 30, but this is become 30x square into C3. Yeah, so 2x into this, so this is become minus 0.6x square, and this 6 into this is become minus 12x bracket complete dx is equals to 0. So this is, now we will gather this C2 and C3 term. So gathering that, you will get 6x cube plus 2x square minus 12x square minus 4x into C2. Similarly, C3 term, so this is become 3x raised to 5 plus 15x cube. Due to this minus sign, this sign will be changed. So this is become minus 6x raised to 4 minus 30x square into C3. So now we'll see the constant. So this is constant is nothing but minus 3x cube minus 6x square, but due to this minus sign, this sign will be changed. So this is become 0.6x square plus 12x dx is equals to 0. So now I will do the integration of this term. So after integration, I will get 6x raised to 4 upon 4 plus 2x cube upon 3 minus 12x cube upon 3 minus 4x square upon 2 0 to 1 C2 plus 3x raised to 6 upon 6 plus 15x raised to 4 upon 4 minus 6x raised to 5 upon 5 minus 30x cube upon 3 and upper limit and lower limit C3. Similarly, this is become minus 0.3x raised to 4 upon 4. So this is our upper limit or lower limit. 6x cube upon 3 0 to 1 plus 0.6x cube upon 3, this is also 0 to 1, and plus 12x square upon 2 0 to 1 is equals to 0. Now I will put upper limit and lower limit in this equation by using upper limit minus lower limit formula. So this is become 6 by 4 plus 2 by 3 minus 12 by 3 minus 4 by 2 C2 plus 3 by 6 plus 15 by 4 minus 6 by 5 minus 30 by 3 C3 minus 0.3 by 4 minus 6 by 3 plus 0.6 by 3 plus 12 by 2 is equals to 0. So if I'm putting this equation in calci, so I will get minus 3.833 C2 minus 6.95 C3 plus 4.125 is equals to 0. So this is my equation. So I will put my 3.833 C2 plus 6.95 C3 is equal to 4.125. So this is my equation number 1. So I got equation number 1 by using this weighted function 1. Now similarly I will solve for weighted function 2. So I will get second equation, and after putting this equation 2 equation in calci, I will get the value of C2 and C3. So this is equation number 1 by using weighted function 1. Similarly, we will put weighted function 2. So step number 2, W2 is equals to, now my weight function for Galerkin method is coefficient of Ci in Y. I solve for C2, now I will solve for C3. So if I am seeing that the coefficient of C3 is x cube minus 3x, so my W2 will be x cube minus 3x. Now I will put this W2 in this residue equation. So that is become 0 to 1 w2 r dx is equals to 0. So this is become 0 to 1 w2, which is nothing but x cube minus 3x into r. So r is nothing but our residue, which is nothing but 6x plus 2 into C2 plus 3x cube plus 15x into C3 minus 0.3x minus 6 dx is equals to 0. So now I will multiply this through bracket, and after multiplying and integrating this bracket, I will get minus 7.3 C2 minus 13.371 C2 plus 7.74 is equals to 0. So this is our equation number 2. If I am putting this in right side, my equation become 7.3 C2 plus 13.371 C3. So this is C3 and is equals to 7.74. So this is my equation number 2. So I got equation number 1, equation number 2. If I am putting this equation 1 and equation 2 in calci, I will get the value of C2 and C3. So if I am putting these two equation in calci, I will get the value of C2 is 2.640 and value of C3 is minus 0.8624. So I got the value of C2 and C3, but you have to find the value of y of 0.2. So I will put this y of 0.2 in this approximate polynomial equation. So this means that when we have to find the value of y when the x is 0.2. So simply you will put x is equals to 0.2 in this equation. So and C2 C3 value in this equation. So after putting this equation, so I will get y of 0.2 is 0.5801. So that's the end of our y of 0.2 by using Galerkin methods. So now we will see Petro-Galerkin method. So my method number 2 is Petro-Galerkin method. Okay. So for Petro-Galerkin method, my weight function will be any algebraic polynomial. Okay. So first we will decide what is my weight function. So already in last sum we know that any algebraic polynomial is nothing but in terms of x any function. So I will assume w1 is equals to x and w2 is equals to x squared. You can assume x cube also, x raised to 4 also, x raised to 5 also. But if you assume x raised to 5, x raised to 6, then my integration complexity will be increased. So always assume w1 is equals to x and w2 is equals to x square. So let us try solve for w1. So this is become 0 to 1 w1 into 6x plus 2 into C2 plus 3x cube plus 15x into C3 minus 0.3x minus 6 dx is equals to 0. So I will put w1 as a x. So 0 to 1 x into 6x plus 2 into C2 plus 3x cube plus 15x into C3 minus 0.3x minus 6 dx is equals to 0. So now I will multiply this x throughout this equation. So after multiplying this, I will get 0 to 1. This is become 6x square plus 2x into C2 plus 3x raised to 4 plus 15x square into C3 minus 0.3 x square minus 6x dx is equals to 0. So this is my bracket multiplication. Now I will integrate this term. After integrating this term, I will get, so 6x cube upon 3 plus 2x square upon 2. This is C2 and bracket limit will be 0 to 1 plus 3x raised to 5 upon 5 plus 15x cube upon 3 into C3 0 to 1. Now this is become minus 0.3 x cube upon 3 0 to 1 minus 6x square to 0 to 1 is equals to 0. So this is my 0. Okay. So now I will put upper limit and lower limit. So I will get, after putting upper limit and lower limit, so this is become 6 by 3 plus 2 by 2 into C2 plus 3 by 5 plus 15 by 3 C3 minus 0.3 by 3 minus 6 by 2 is equals to 0. So after putting this equation in calci, I will get 3C2 plus 5.6 C3 minus 3.1 is equals to 0. So I got equation 3C2 plus 5.6 C3 is equals to 3.1. So this is my equation number 1. Okay, so I got equation number 1 by using this W1 function, weighted function 1. Now similarly I will solve for W2 and I will get the equation number 2. So let us try with equation number 2. Let W2 is equals to x square. Similarly same process, you will put this W2 x square in this residue form equation. So you will get 0 to 1 x square into 6x plus 2 into C2 plus 3x cube plus 15x into C3 minus 0.3x minus 6 dx is equals to 0. So I will multiply this x square throughout bracket. So after multiplying this, I will get 0 to 1 6x cube plus 2x square into C2 plus 3x raised to 5 plus 15x cube into C3 minus 0.3 x cube minus 6x square dx is equals to 0. Now I will integrate this term. After integrating this term, I will get 6x raised to 4 upon 4 plus 2x cube upon 3 into C2 plus 3x raised to 6 upon 6 plus 15x raised to 4 upon 4 into C3 minus 0.3x raised to 4 upon 4. So this is 0 to 1, here also 0 to 1, here also 0 to 1, upper limit and lower limit, and this is become minus 6x cube upon 3 0 to 1 is equals to 0. This is will be 1. Okay, so now I will put this upper limit and lower limit in this equation. So this is my equation become 6 by 4 plus 2 by 3 into C2, okay, plus 3 by 6 plus 15 by 4 into C3. So this is 15 minus 0.3 by 4 minus 6 by 3 is equals to 0. Now I will put this equation in calci and I will get proper equation. So after putting this equation in calci, I will get 2.17 C2 plus 4.25 C3 minus 2.075 is equals to 0. After rearranging this, I will get 2.17 C2 plus 4.25 C3 is equals to 2.075, which is our equation number 2, and this is my equation number 2. Okay, so I got equation number 1, I got equation number 2. Now I will put this two equation in Calc, and after putting this equation, you will get the value of C2 and C3 and you will get the value of y of 0.2. So let's put this equation in Calc. If I'm putting this two equation in Calc, I will get the value of C2 and C3, which is C2 value is 2.600 and C3 value is minus 0.8394. I will put this C2 and C3 in this approximate polynomial because we want the value of y of 0.2. If I'm putting this C2 and C3 and x 0.2, I will get y of 0.2 is equal to 0.5809. So that's the end of our Petro-Galerkin method. We find the y of 0.2 by using this Petro-Galerkin methods. Now we will solve Rayleigh's method. So Rayleigh RR method, which is also known as Rayleigh's method. So we know that for Rayleigh's method, the step is different. So in this method, we will do 0 to 1 Wi r dx is equals to 0. So we will not use this residue equation. We will do only use differential equation for that. So this is become 0 to 1 Wi into r. So in this case, r will be our differential equation. So d square y upon dx square minus 3x dy by dx minus 6y dx is equals to 0. Now I will multiply this wi throughout this bracket. So my equation becomes 0 to 1 wi into d square y upon dx minus 3 wi x dy by dx minus 6 wi dx is equals to 0. So now we will solve each step integration. So if I'm putting this first term integration, so let's see first term integration. So let's see 0 to 1 wi d square y. So this is dx square, d square y upon dx square. So if I have to find this integration, you should use integration by part formula, which is nothing but your UV formula. So my UV formula u will be u integration of v minus big integration of v into du by dx big dx. So by using this formula, I will use this formula on this method. So this is my u and this is my v. So u integration of this term, which will be the dy by dx minus integration of v, which will be the dy by dx into dwi upon dx dx. So this is a solved term for my first term. Now I will put this solved term in this equation. So my equation looks like 0 to 1. So 0 to 1. So you already find the integration for that. So I will write directly wi dy by dx minus 0 to 1 dy by dx into dwi into dx minus integration of 0 to 1 3 wi x dy by dx minus 0 to 1 6 wi y dx is equals to 0. Here also one dx term will be there. So minus. Okay. So now we will solve this integration. So I will put this all data to RHS side. So my equation look like wi dy by dx is equals to 0 to 1 dy by dx into dwi dx dx minus 0 to 1 3 wi x dy by dx into dx plus, so this is also become plus because you put this data to RHS side. So 0 to 1 6 wi y dx. Now, so for solving this equation, if I am seeing this equation, I require dy by dx, I require dwi by dx. So first we will find what is dy by dx and what is d square by dx square. So this is my, this is term become, this is also solvable integrations, but you have to put limit also. So I am putting 0 to 1 also here also. So now what we'll see, the if I'm seeing, recall this Rayleigh's method. For solving Rayleigh's method, our approximate solution is totally depend on our essential boundary condition. And if I'm seeing this sum, the number of essential boundary condition is only one. So my approximate solution for this method will be y is equals to c0 plus c1x plus c2x square. Since my essential boundary condition is only one is there, so that's why my order of polynomial equation is 2. If it is essential boundary condition is 2, then my order will become 3. So that is the concept for polynomial for Rayleigh's method. So y is equals to c0 plus c1x plus c2x square. Now I will put this boundary condition through this equation. So this is become y of 0 is equals to c0 plus c1 into 0 plus c2 into 0. So y of 0 is 1. So I will get c0 is equals to 1. Now I will put this c0 is equals to 1 in this equation. So my equation become 1 plus c1x plus c2x square. So this is my y equation. Now if I am seeing that I require dy by dx also, so I will find derivative of this also. So I will get c1 plus 2c2x. So I got y, I got dy by dx. So if I am seeing this my throughout equation, I got dy by dx, I got y also, but if I am seeing that the wi is missing, so what is wi? So wi is nothing but weight function, and for Rayleigh's method, weight function is nothing but any algebraic polynomial. So any algebraic polynomial which is nothing same as a Petrov-Galerkin method. So in whatever considering Petrov-Galerkin method, the same will be assumed in Rayleigh's method. So I will consider W1 is x and W2 is x square. So let us solve for first W1 is equals to x. So W1 is equals to x. So if I am saying that I require dw upon dx also, so I will find dw1 upon dx, so which is nothing but equals to 1. So now I will put all this data in this equation. So my equation become x dy by dx 0 to 1 is equals to 0 to 1. So dy by dx, what is dy by dx? dy by dx is nothing but this our term, which is nothing but c1 plus 2c2x into dw1 by dx. So that is nothing but 1. So into 1 dx. So one term is completed. Now we will see the second term. My second term saying that 0 to 1, 3 is our constant. So taking outside of integration term, w1 which is our x, x into x which is our x square. So x square into dy by dx which is nothing but c1 plus 2c2x. So third term is also completed. Now we will see the third term. So third term is nothing but 1, 6 common, 0 to 1, w1 which is our x into y which is nothing but 1 plus c1x plus c2x square into dx. So this is our 1 and y is getting from this term. So I got 3 term. This is first term, this is second term, this is third term. Now I will integrate all this term. After integrating term, I will get x dy by dx 0 to 1 is equals to, so if I am putting integrating this term, so integrating this term you will get c1 0 to 1 c1 plus 2c2x plus this is become 3x square c1 plus 3x cube, 3 2s are 6, so 6x cube c2 I'm merging this whole bracket. I will take C2 and C1 as a common, and after that I will solve integration. So C1 plus 2C2 is over. Now this 3x square multiplied to C1 multiplied to 2C2x will become 6x cube. Now this third term will be plus 6x plus 6C1x plus 6C2x square. So this is our C1. 6C2x square. So this is 6C2x square, 6C1x, 6x, and this is my dx. Okay, so now I will take C1 as a common factor, C2 as a common factor. So after that I will get x dy by dx 0 to 1 is equals to, okay, 0 to 1. So if I am seeing that this is C1 term, this is also C1 term, and this is also C1 term. If I am taking C1 as a common, so I will get 1 plus 3x square plus 6x into C1. So that is C1 factor. Now I will first solve for C2. So solving for C2 I will get 2x plus 6x cube plus 6x square into C2. And so this is my equation number 4, solve for C1 and solving for C2. So if I'm seeing that I got the three terms, one is W1, Y, second is this. After solving this all this term, I will get this equation. Now I will do the integration for that. So integration for that will be x dy by dx 0 to 1 is equals to x plus 3x cube by 3 plus 6x square by 2 into C1 plus 2x square upon 2 plus 6x raised to 4 upon 4 plus 6x cube upon 3 into C2. Limit will be 0 to 1, 0 to 1. Now I will put this equation in calci, but before putting this in calci, let us see what is this concept. So if I'm saying that, this means that dy by dx and limit is 0 to 1. If I'm saying dy by dx, what is dy by dx? dy by dx is our secondary variable, and boundary condition associated with this variable, which is known as a natural boundary condition. If I'm saying my sum, there is a two boundary condition. One is the essential, which is related to primary. Second is a natural, which is related to secondary. So y dash, which is nothing but dy by dx, which is nothing but secondary variable. So I have a value for secondary variable boundary condition is 0.1. So simply in terms of this, so this is related with a secondary boundary condition, secondary variable. Secondary variable which is known as a natural boundary condition, which is our y dash 1 is equals to 0.1. So in the place of dy by dx, I will write 0.1 is equals to 1 plus 3 by 3 plus 6 by 2 into C2 into C1 plus 2 upon 2 plus 6 by 4 plus 6 by 3 into C2. Now, now I will put this equation in calci and from calci, but there is a one problem is that. So if I'm saying that this is a d square by dx square plus 3x, so if I'm writing that, this will be the plus, so this is also plus, and if I'm writing here is also, this is also plus, plus minus, this is also plus, and if I'm putting this equation in RHS side, so this become minus and this is plus. So if I'm, this equation will become, so minus plus, this is C1 plus 2C2x, this is minus, again this become minus, so this is become plus, so C1 plus 2C2x, so if I'm C1 term, so C1 minus 3x square plus 6x into C1, again for C2 is 2x minus 6x cube minus 6x cube plus 6x square into C2, and the remaining term as it is. If I'm integrating this sum, integrating you will get, so one integration is x and this is become minus 3x cube by 3 plus 6x square by 2, and this is become 2x square by 2 minus 6x raised to 4 by 4 plus 6x by 3. And if I'm putting this upper limit and lower limit, my equation look like, so I will get equations in terms of 2c1 plus c2 is equals to minus 2.9. So this is my equation number 1. So similarly, I will find for W2, and my W2 value will be the x square. It's the same process. You will put W2 x square and you will solve for similar process. I am solving for W1. Now I will be solve for W2. So let us put W2 instead of W1. So my function become x square dy by dx 0 to 1 is equals to 0 to 1 dy by dx. So dy by dx is nothing but our c1 plus 2c2x into dw2 by dx. So simply you have to derivative of this with respect to x, which is nothing but 2x. So you will write 2x dx, right, minus 3 into w2, which is nothing but our x square. So x square into x dx into dy by dx, which is nothing but c1 plus 2c2x dx. So this is second term, which is 0 to 1. I solve for first term, then this second term. Now the third term is remaining is 0 to 1 6 into x square into y. So y is nothing but our equation, which is equals to 1 plus c1x plus c2x square dx. So simply we will solve this bracket. So you will get 0 to 1. So this is become 2x c1 plus 4x square c2 minus 3x cube into c1, 3x cube into c1, 3x cube into this become 6x raised to 4, 6 minus 6x raised to 4 c2. Okay, next plus 6x square plus 6x square plus 6x cube c1 plus 6x raised to 4 c2 dx is equals to 0. Dx is equals to 0. This is equal, not 0. This is dx. Okay. So again the same, you will we will bifurcate this c1 and c2. So you will get x square dy by dx 0 to 1 is equals to, so this is c1 term, this is c1 term, this is also c1 term, this is also c1 term. If I am taking c1 as a common factor, I will get 0 to 1 2x minus 3x cube plus 6x cube into c1 into c1. If I am taking x c2 as a common factor, you will get 4x square minus 6x raised to 4 plus 6x raised to 4. This is c2. So next is remaining is, I complete c1, I complete c2. The remaining factor is 6x square only. So this is as it is. You will write plus 6x square dx is equals to is dx only. Okay, so I will recheck again. So this is 2x c1, this is 3x cube c1, and this is 6x cube c1, right? Next, this is 4x square, this is 6x raised to 4, and this is plus 6x raised to 4, and 6 square term is as it is. So now I will do the integration for that. The same concept, whatever written in first step, where this is boundary condition related to natural boundary condition. So my natural boundary condition is 0.1. So I will write simply at 0.1 is equals to 2x square by 2 minus 3x 4 by 4 plus 6x raised to 4 by 4, 0 to 1 into c1. Again this 6x raised to 4 plus minus will be cancelled. So remaining will be 4x cube by 3 into what, c2, plus 6x cube by 3. You will write upper limit and lower limit. So if I am putting this in upper limit and lower limit, so my equation become 6 by 4 into c1, same as it is 4 by 3 into c2, and this is become 6 by 3. So now I will put this in calci and I will get the complete one equation. So after solving this equation, you will get 1.75 c1 plus 1.33 c2 plus 2 is equals to 0.1, which is nothing but 1.75 c1 plus 1.3 c2 is equals to minus 1.9. So this is my equation number 2. So after putting these two equation in calci, this equation we got from step number 1 and this is for W2. So if I am putting this equation in calci, so I will get the value of C1 as minus 2.150, minus 25150, okay, and C2 is nothing but 1.4010, 1.4010. So I have to find the value of y of 0.2, but in this case this will be not my y. My y will be this. Y is equals to 1 plus c1x plus c2x square. Why? Because in Rayleigh's method, your polynomial will be changed. So therefore, my y equation will be 1 plus c1x plus c2x square. So therefore, now I will put this c1 and c2 in this equation. So if I am putting this c1 and c2 in this equation, I will get y of 0.2 is equals to 0.6259. 0.6259. So I got the y of 0.2 value by Rayleigh's method. So in this, what is the conclusion from this? You have to assume polynomial as per our differential equation. Okay, so this is always depend upon your essential boundary condition. So do not forget to write the right approximate solutions. So this solution will be depend on your essential boundary condition. So that's the end of our Rayleigh's method. So now we solve Galerkin method, we solve Petrov-Galerkin method, we solve Rayleigh's method. Now we will do the least square method. So my list number 4 is least square method. So method remains same, whatever you apply for Galerkin method and Petrov-Galerkin method, only the difference is weight function. If I am seeing this table, for least square method, my weight function says that delta R upon delta CA. So let's see what is this delta R upon delta CA. So we know that my R is this. So you have to differentiate R with respect to parameter. So I have two parameter, one is a C2 and one is a C3. So if I am differentiating first with a C2 and second will be with a C2. So let's see. This will be W1 is equals to delta R upon delta C1. So let's see, W1 is equals to, so my R is this. So I will differentiate this with respect to first parameter, which is our C2. So this will become C2. So this will be the 6x plus 2. So my W1 will be the 6x plus 2. So now I will put this W1 in this residue equation. So therefore I will get 0 to 1 6x plus 2 into 6x plus 2 C2 plus 3x cube plus 15x C3 minus 0.3x minus 6 dx is equals to 0. Now I will multiply this 6x2 throughout this bracket. So after multiplying this I will get 0 to 1. This is become 6x plus 2 bracket square into C2 plus this multiply to this, you will get 6x plus 2 into 3x cube plus 15x into C3 minus 0.3 into 6x plus 2, 0.3 x into 6x plus 2 minus 6 into 6x plus 2 dx is equals to 0. So now I will solve this bracket first. After that I will do the integrations. So if I am solving this bracket, I will get 0 to 1. So this is become, this will, I will treat as it is. Okay, so I will multiply this two bracket. If I am multiplying this, so after multiplying I will get 6x into this will be the 18x raised to 4, 6x into this will be the 90x square plus 2 6x cube plus 30x into C3. Okay, so I will multiply this 0.3x into this, so this is become 1.8x square plus 0.6x, and this is become minus 36x square plus 12 dx is equals to 0. So I will integrate this term. After integrating I will get 0 to 1. So this is become, so I am integrating this term, so I will not write integration term formula. So direct this will be the 6x plus 2 bracket cube upon 3 into C2, and our limit will be 0 to 1. Similarly, this is become 18x raised to 5 upon 5 plus 90x cube upon 3 plus 6x raised to 4 upon 4 plus 30x square upon 2 into C3 0 to 1. So next step will be integration of this term minus 1.8 x cube upon 3 plus 0.6 x square upon 2, this is 0 to 1, minus 36x cube upon 3 plus 12x 0 to 1 is equals to 0. So now I will put upper limit and lower limit in this equation. So my equation look like, so I will put x is equals to 1. So 6 plus 1, 6 into 1 is 6, 6 plus 2 is 8. So my equation become 8 cube upon 3 minus lower limit is 0. So this will become 2 cube upon 3 into C2 plus similarly this is become 18 by 5 plus 19 by 3 plus 6 by 4 plus 30 by 2 into C3 minus 1 by 8 by 3 plus 0.6 by 2 minus 36 by 3 plus 12 is equals to 0. Now I will put this equation in calci and you will get a proper one equation. Okay, so this is equation after multiplying 6x plus 2 throughout this bracket. So if I am multiplying bracket, you will get 0 to 1 6x plus 2 bracket square into C2 plus, if I am multiplying 6x square, this is become 6x into this, so this is 18x raised to 4 plus this is become 90x square plus 6x cube plus 30x into C3. Okay, next is 1.8x square plus 0.6x, and this has become 36x plus 12 dx is equals to 0. So now I will do the integration of this term. So after integration of this term, you will get, so this has become 6x plus 2 bracket cube upon 3, but coefficient of x, so which will be the 6, 0 to 1 into C2 plus 18 x raised to 5 upon 5 plus 90 x cube upon 3 plus 6x raised to 4 upon 4 plus 30x square upon 2 into C3 0 to 1. So this has become minus 1.8 x cube upon 3 plus 0.6 x square upon 2 0 to 1. Yeah, this has become minus 36x square upon 2 plus 12x 0 to 1 is equals to 0. So now we will put this upper limit and lower limit in this equation. So my equation become 1 by 18 as common. I will put x is equals to 1. So this is become 18 cube. This is 18. 8 cube minus 2 cube. C2 plus this is become 18 by 5 plus 90 by 3 plus 6 by 4 plus 30 by 2 into C3 minus 1.8 by 3 plus 0.6 by 2 minus 36 by 2 plus 12 is equals to 0. After putting this in calcium, you will get the equations 28C2 plus 50.1 C3 minus 30.90 is equals to 0. So I will rearrange this equation. So 20C2 plus 50.1 C3 is equals to 30.90. So let us see, assume this is equation number 1. So now we will solve for W2. So my W2 will be delta R upon delta C3 because our second weight parameter is C3. So you will, this is my R term. You will differentiate with respect to C3. After differentiation, you will get W2 is equals to 3x cube plus 15x. So now I will put this W2 in this equation. So my equation become 0 to 1 into 3x cube plus 15x into 6x plus 2 C2 plus 3x cube plus 15x C3 minus 0.3x minus 6 dx is equals to 0. So if I'm solving this equation after solving this bracket and after integration, you will get 50.1 C2 plus 94.286 C3 minus 51.18 is equals to 0. So now I will rearrange this equation. So you will get 50.1 C2 plus 94.286 C3 is equals to 51.18. So this is my, let us assume this is equation number 2. Okay. After putting this two equation in calci, I will get the value of C2 is equals to 2.687 and the value of C3 is equals to minus 0.885. If I am putting this C2 and C3 in this equation, you will get the value of y of 0.2. So I will put this C2, C3 in this equation. So my final answer will be y of 0.2 is equals to 0.5766. 0.5766. So this is my final answer. So if I am putting this C2 and C3 in this equation, you will get the value of y of 0.2, which is nothing but 0.5766, or that's the ends of least square methods. Thank you.